Okay, today we're going to learn about relative formula mass. Relative formula mass is something that they always ask about in exams. Very important. And the foundation of it comes from the periodic table, which we have down here to the left. So let's just take a look at a basic molecule, for example. Let's look at H2O. Here's the chemical formula for H2O. Okay, most people know what this is. And you can see that in the chemical formula, it has two hydrogens, which is here, and one oxygen. This is the chemical formula of H2O, but you can also imagine it as a molecule, something like that. That's the same thing, H2O. Now, each one of these circles represents an atom. So this is an atom of hydrogen, this is another atom of hydrogen, and this is an atom of oxygen. And atoms, of course, are mass, they're matter, so they have a weight. So we could look at the periodic table, and that will give us the mass, the relative atomic mass of each particular atom. So for hydrogen, if you look on the periodic table, you see a box like that, you see hydrogen, and it has 1 and 1 on it, okay? And in this periodic table, the bottom number happens to be the relative atomic mass. Now, if we look at oxygen on the periodic table, the symbol O, you see 8 and 16. Again, the bottom number, the larger number, is the relative atomic mass. Every periodic table is different, so you have to look at the key. But in this one, the bottom number, the larger number, is the relative atomic mass. So that means for this molecule of water, H2O, each hydrogen is worth 1. So here is 2 hydrogen, so that's going to be 1 times 2, which equals 2. And here for oxygen, there's 1 oxygen, so that equals to 16 of the relative atomic mass. So in total, that equals 18. So the relative formula mass of water is 18. Okay, and so that's how you do it. So let's try another one. Let's keep it simple. Let's erase all of that. Use a different eraser. No, I don't like that one. Let's use this one. So erase that. Erase that. Erase that as well. So let's try another one, relative atomic mass. Let's look at carbon dioxide. Carbon dioxide. So we see carbon dioxide has 1 carbon. If we look at the carbon is there, that's got a relative atomic mass of 12. And then oxygen, it's got 2 of them, and that has a relative atomic mass of 16 times 2, which equals 32. And if we add that together, 32 plus 12, that's going to be equal to 44. 44. And that's the relative formula mass of carbon dioxide. You can even do bigger molecules. C6H12O6. All of our GCSE students should know what this is. This is glucose. And how would you find a relative formula mass of this? Well, you follow the same procedure. 12 times 6 for carbon. 12 times 1 for hydrogen. And then 16 times 6 for the oxygen. And then you add them all up together. Okay, 96. 12 times 1 is 12. And then the 12 times 6. Oops. 12 times 6. See if it gives us that. Let me work that out. $72. Add them all together. 72 plus 12 plus 16 times 6, which was 96. And if we add them all together, 72 plus 12 plus 96 is 180. So that's the relative formula mass. A very important concept, because you need this concept to do percentage by mass, which we're going to look at in another video.